this second chapter of trigonometry, we were going to be extending our knowledge of the trig functions. In this lesson, we're going to look at problem solving using the sine and cosine functions.
Okay, well, there's actually not a whole lot to be said by way of introduction to this. It's basically just something we got to jump into here. But what I can say before we get into problem solving here is that problems, okay, should be in radians. Okay, so problems are in radians. And the reason for that is because radians offer a nice relationship between an angle and a length. Okay, it's a direct relationship. There's no conversions required, so it's a really useful tool to use as radians. Secondly, remember that your max value is going to be the median plus the amplitude, and then the minimum value is going to be the median minus the amplitude. These tend to be quite useful equations when we're working through word problems here. But let's just jump right in.
The minimum depth, d meters, of water in a harbor, t hours after midnight, can be approximated by the function d of t is equal to 14 plus 3 times the cosine of 0.5t, where t is between 0 and 24.
Okay, so now given that equation here, the first thing we're supposed to do here is to determine the maximum and minimum depths of the water in the harbor. Well, this can be easily done if we recognize what the a value is and what the d value is. Now, don't get thrown off by the fact that 14 comes first here. Remember, the a value, or the amplitude, is always the coefficient of the trig function here. So the amplitude in this case is 3. The d value is the constant added at the end. In this case, that's 14. Try not to get thrown off by the fact that the 14 comes first when we write it out here. A lot of times people just read that and think, you know, a comes first. A has to come first. If it comes first, it's got to be a. Well, that's not necessarily true. They are free to change the order as they wish here. So watch that. So now our maximum is simply going to be that d value plus the a value, so 17. And our min is going to be the d value minus the min value. In this case, it's going to be 11. So the maximum depth is going to be 17 meters, and the minimum depth is going to be 11 meters. Okay. Now let's move on and take a look at the period. Determine the period of the function. Well, the period, okay, is going to be determined by 2 pi divided by the b value. And in this case, the b value is 0.5. So we're going to have 2 pi divided by 0.5. And I know a lot of us are going to jump on this right away and say, I know what that is. That's 2 pi over 1/2. And when you divide by a fraction, you multiply by the reciprocal. So the answer is going to be 4 pi. And that's great, and that's true, but that's kind of a weird answer. If you were standing on the shore and someone came up to you and asked, you know, hey, so how long does it take the tide to come in and out here? And you looked at them and said, well, it takes 4 pi. Well, you're kind of a jerk, okay? That's a weird way to answer that question here. We want to convert that into time. So we're going to go to the calculator here, and we're going to enter 4 pi. And I get 12.56. Now, please, 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 I beg of you, this is not 12 hours and 56 minutes here, 57 minutes. Time is not metric. Okay, it's 12 hours. Okay, so this becomes 12 hours, and then what's left over here is a fraction of an hour. This is 0.566 blah 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 of an hour. So take the 12 off there, and now you're just left with, okay, the fraction here. Multiply that by 60. Oh, and it's basically 34 minutes. We're rounded to the nearest whole minute here. So it's going to be 12 hours and 34 minutes. Okay, that's a much better answer here. The next question says, what is the depth of the water to the nearest tenth of a meter at 3 a.m.? Okay, now when we're working with questions like this, we're going to be working typically on the 24-hour clock. Now that's not such a big deal in this particular problem here, but we would be working on a 24-hour clock. And we should be able to just plug in the value for t that we're getting here. So really, this is just a matter of plugging in the 3 o'clock for t. So that's going to be 14 plus 3 times the cosine of 0.5 times 3. Okay, and again, I would just do this on my calculator here. So it would be, again, 14 plus 3 cosine of 0.5 times 3. There's the 3 in the morning. And the answer is it would be 14.2 meters. Okay, 14.2 meters. Now the last question here says, a ship which requires a minimum of 11.5 meters of water is in harbor at midnight. By what time to the nearest minute must it leave to prevent grounding? Okay, so in this case we're given the depth and we're being asked for the time. Now, in this chapter, in this course here, the expectation really is that you're going to do this with your calculator. Okay, so let's go to the calculator here. This isn't me kind of cheating here. Sorry, what this is me showing you what the expectation is. So first of all, I'm going to enter in the equation 14 plus 3 cosine of 0.5 x. Okay, there's the equation. And then I know that I need a minimum of 11.5. I think it was 11.5. Yeah, 11.5 meters of water. So I'm going to put those two in. Before I jump right to my graph, though, I'm going to go to my window setting and adjust it here. I want to make sure I can see everything. Now, horizontally, the question gave me what the domain should be. Right at the beginning here, it said 0 to 24. So I'm going to use that. So 0, 24, and I don't mind if the scale, let's say the scale goes up by 3 hours. That doesn't really make much difference because I'm not going to read that off here. But I do know that the minimum value was 11 and the maximum value was 10. I figured that out in the first question. So I'm going to give 17. The maximum value was 17. The minimum value was 11. So I'm going to give myself a little bit of leeway there. I'm going to make my minimum 9, and I'll make my maximum 20. And that can go up by ones here. And so now if I graph that, all right, there they go. So the first time, okay, so you got the boat on here and the tide goes down. The boat has to leave before this time or else it's going to hit the ground here. So I need to figure out that point of intersection. So we press second trace to get into our calc menu here. And I'm looking for that point of intersection. Press enter, that's number 5. And I'm going to move that cursor close to that point of intersection right there. Now, it doesn't have to be right on top of it, but it's got to be right close to it here. Press enter because I'm on the first curve. Now it did drop me down a little bit. It's on the second curve. Press enter. It wants to make this as a guess. Don't worry about it. Just press enter. Okay. And notice that our x value here is 5.11 and so on. Now my y value is 11.5. That was the depth. It's this number that I'm looking for. That's the time. Okay. Now I'm going to quit. Go back to my home screen here. The calculator does a wonderful thing when you find a point of intersection. It actually memorizes that point. So right now if I press X and enter, that's the point that it found. Now I'm not going to say 5.11 in the morning. That just doesn't make much sense. That's not a good way of describing that. I do know, however, that 5 hours have passed. So I do know that this is going to be 5 o'clock in the morning. I've got to figure out what fraction of an hour, how many minutes have passed by here. It's the 0.1118 blah blah blah. That represents the fraction of an hour beyond that. So I'm going to subtract the 5 off of that because I already know the 5 hours have gone by. I got to figure out how many minutes this is. So I'm going to multiply this by 60, okay, because this is a fraction of an hour. If I multiply it by 60, it'll tell me how many minutes you've got. And 6.7 minutes. Okay? Now, I don't want to round this up. I mean, I want to be safe for this guy in the boat here. I don't want him to hit the ground here, so I'm going to round that down to 6 minutes. So to the nearest minute, to be safe here, whoever's in that boat has to leave by 5:06 a.m.
A nail is caught in the tread of a rotating tire at point N in the following diagram. The tire has a diameter of 40 centimeters and rotates at 10 revolutions per minute. After 4.5 seconds, the nail touches the ground.
So our first question here tells us to determine the equation for the height of the nail as a function of time in the form, and they give us the equation right here where a is greater than 0. Okay, so let's just go back and read this again here. It says the tire has a diameter of 40 centimeters. Now that means that the radius is equal to 20 centimeters. That right there is the amplitude. Okay, our amplitude is going to be 20. Now that has to be the case with a wheel here. Okay, because remember, the amplitude is the distance from the center of the motion to the top, center of the motion to the bottom. Now, the hub of the wheel, or where the axle is here, that is the center of motion here. And the distance from the center of the wheel to the edge, that's the radius. So the radius is the amplitude. So our amplitude is 20. That's easy. The d value is also fairly easy to determine here because the wheel is resting on the ground. So the distance from the center of the wheel to the ground, we'll just look at it. It's the radius. So if the radius is 20, that means the d value is also 20. Now, that's important. When these two are the same, when a is equal to 20 and d is equal to 20, when these are the same value here, this wheel is on the ground. This object that's going through sinusoidal motion is touching the ground. Okay, now, notice that in the equation I'm looking for, I'm not even required to figure out what c is. Okay, it's not asking me that. So I just need to figure out what b is right now. But I've done this question enough with people to know that this is confusing. We are told that it takes this thing rotates here at 10 revolutions per minute. Now that means that in 1 minute this thing goes around 10 times. Now let's just think about what that means per revolution. Okay, if it was to go around once in a minute, then the period of that motion would be 60 seconds. It would take 60 seconds to go all the way around. If it went around twice in a minute, okay, then each revolution here, each going around would take 30 seconds. After 30 seconds, I'd be right back to the beginning. I'd go around, and there it is. 30 seconds later, I'd done it twice. So if it was 2 revolutions per minute, each revolution would be 30 seconds. The period would be 30 seconds. If it's going around 10 times in a minute, 10 times in a 60-second period, okay, then each one of those revolutions must be 6 seconds. Okay, just divide the 60 seconds by 10. Okay, once around for 6 seconds, twice around takes me up to 12, 3 times around takes me up to 18, and so on, up to 60 seconds. Okay, now if that is obvious to you from the beginning, that's wonderful. But I've done this question with enough people to know that the difficult part here is trying to figure out what the heck the period is. In this case, the period is 6 seconds. Now, we still have to figure out what b is. And b is going to be 2 pi divided by the period, or 6 seconds. And so my b value here is going to be pi over 3. So thus, we can put together the equation y is equal to 20 sine of pi over 3 x, or t. They've got t here. Sorry, I probably should have used h instead of y, actually, as a matter of fact. H is equal to 20 sine of pi over 3t plus 20. And so there's the equation that we're looking for. Now let's move on and take a look at b. b says, how far to the nearest tenth of a centimeter is the nail above the ground after 7 seconds? Okay, so now we're giving us a time here. All we really got to do is plug this into the calculator. Okay, so I got to make sure I'm in radian mode. Okay, and I am in radian mode. And so now, if I quit here, I'm just going to enter this in. 20 times the sine of pi divided by 3, this time times 7. Okay, we're plugging in 7 seconds, and that's inside the sine function. Plus my d value was 20. And then the answer is 37.3 centimeters. So 37.3 centimeters, and I got that just by plugging that in. The next question here says, when does it hit when does it hit 33 centimeters above the ground for the first time? Now, once again, this time I'm asking for the x value. I'm giving you a y value. Okay, I'm giving ourselves a y value, or the value of the dependent variable, and I'm trying to figure out what the time is. The assumption here is that you're going to take and plug this into the calculator. Okay, so let's enter in our function. It's going to be 20 sine of pi divided by 3 x plus 20. Okay, now I'm also going to plug in 33 because I want to know where it hits 33. Okay, I'm going to look for where those two things overlap here. I'm going to go to my window here, and my window settings are still kind of set for that last one there. But I'm going to plug that in. Now I know that it revolves once every 6 seconds. So what I'm going to do here, though, I'm going to plug in maybe make it, let's say, 12 seconds for 2 revolutions there. Scale is being at 3 is probably fine. My min this time, though, is going to be 0. And I'm going to let my maximum be the full diameter. I'm going to let it go from bottom to the top of the screen there. The scale, I don't know, I'll probably let the scale go by 2s just to make that a little bit easier to read. Press graph. There's my wheel going around. There's the 33. And so I'm interested in the time that it hit that 33 for the first time, so right there. So I'm going to go into my calc menu by hitting second trace. We're going to go down to intersect. And I'm going to bring that cursor back close to that point. Doesn't have to be right on it, just close. Enter. It jumped to the second curve there, the straight line. Press enter. It's asking for a guess. Just press enter. Now, it's hard to see that, so I'm going to go back to my home screen. I'm just going to press X and have it pull it up here. Okay? So, it gets there incredibly quickly, okay? Very, very quickly. It gets there at point, what is it? What does it ask for here? Well, it just says when does it hit it. So, let's say, we'll round this to the nearest hundredth at 0.68 seconds. Okay? At 0.68 seconds. It gets there really, really quite quickly.
A Ferris wheel with a radius of 10 meters rotates once every 60 seconds. Passengers get on board at a point 2 meters above the ground at the bottom of the Ferris wheel. A sketch of the first 150 seconds is shown.
Okay, so the first thing that we want to do with this question here is write an equation to model the path of a passenger on the Ferris wheel where the height is the function of time in the form. And they give us the form here. And notice once again that they're not interested in forcing us to determine the horizontal phase shift here. Okay, that has been taken out of it. We need to know A, B, and D here. Now it turns out that's hard enough. And I'll show you what I mean here in a second. So first of all, let's go back up to the question here. Just read it. A Ferris wheel with a radius of 10 meters. Okay, whoa, right there, got it. It has a radius of 10 meters, meaning that the amplitude is 10. I know that right off the bat here, because when we're talking about a circular motion, about a wheel in motion, the radius of the wheel, okay, and this is our 10 meters here, the radius is going to represent the distance from the center of the motion to the top or the center of the motion to the bottom. So, done. Okay, it rotates once every 60 seconds. Well, that's perfect. I love that. I mean, that's exactly what a period is. So our period here is going to be 60 seconds. Now, we still got to figure out what our B value is. Okay, and B is going to be 2 pi divided by the period, which in this case is 60. And so this is going to end up being pi over 30. That's our B value. But that was nice. That just kind of popped right out of that question here. The only thing that we got to figure out now is what the D value is. Okay? But this is the point of difficulty. Now, when we go back up and read this question here, it says passengers get on board at a point 2 meters above the ground. Okay? So now, what tends to happen here for the most part is that people will tell me, oh, well, D must be 2. Because that was the other number that they gave us. It's got to be 2. Okay, let's just think that thing through logically. So let's assume A is equal to 10 and D is equal to 2. If that's the case here, then the maximum value that we get to is going to be D plus A, or 10 plus 2, which is going to be 12. Not a problem. But the minimum is going to be D minus A, okay, or sorry, I got that backwards. I should have written that in this order. 2 plus 10. In this case, this is going to be 2 minus 10, or negative 8. So let's think about that. Let's think about that. So actually, I'll do this over here. What that means is, here's ground level, here's the center of the Ferris wheel, and here's what the Ferris wheel is doing. The top of it is up here at, what did we say? It's going to be up here at 12. The bottom is down here at negative 8. This right here is a little puddle of blood where the Ferris wheel took and crammed you into the ground and pushed you underneath the concrete. There was screaming and people dying. It was terrible. Why do we do this? Okay, why are we doing this? The hub of the wheel has to be higher above the ground than the radius. Okay, so if A is equal to D, what this is mode of transportation. Okay, This is mode of transportation. In one of the previous questions here, that's what we did. A was equal to D, that was the wheel riding along the ground. If you make, in this case here, Ferris wheel, go back to this, A equals D. You think about the Ferris wheel. If you make A equal to D, then this thing is rolling on the ground. You got into it, and then this thing just traveled downtown with you rolling around and around here. If you make A less than D, then this is the scenario going on. People are hitting the concrete and getting pushed underneath here. This is an extreme sport. Okay? It must be the case for Ferris wheels. Okay, it must be the case for Ferris wheels that D is bigger than A. Okay, that the center of the wheel is higher up than the radius of the wheel. Now, just look at the scenario here. This person gets on 2 meters above the ground. The bottom of the wheel is 2 meters above the ground, not the middle of the wheel. D represents the middle of the wheel. Now, the bottom of the wheel is here, then we go from here to the middle, which is 10 meters, and then 10 more meters to the top. So if this is 2 and this is 10, oh, the middle of the wheel is 12 meters above the ground. D is not equal to 2, D is equal to 12. Okay, the wheel here, this distance here is 20. But it's been moved up 2. There's a gap of 2 meters. A gap of 2 meters and then the radius, and then the radius again. I hope that makes sense. I've done this question with a lot of people, and even after explaining it, I still get a lot of people that are not sure they actually visualize what's going on here. They're so thrown off by that 2 meters above the ground. Okay, that's the bottom of the wheel. Bear that in mind. And so now, therefore, my equation is y is equal to 10 cosine. My b value was pi over 30 times, in this case it says x here, and then plus 12. So there's my equation that I'm going to be working with here. Now, the next question says, if Emily is at the bottom of the Ferris wheel when it begins to move, determine her height above ground to the nearest tenth of a meter when the wheel has been in motion for 2.3 minutes. Now, oh, it would be so tempting to be thrown off by this here. Okay, 2.3 minutes is not the value that we're going to plug into this. Okay, because if you come back up to this is in seconds. Okay, our time here is in seconds. So 2.3 minutes, we actually have to convert that to seconds first. So 2.3 minutes is going to be equal to, well, we go to our calculator here, 2.3 times 60, that's 138 seconds. So the question is really asking, how high is she above the ground at 138 seconds? Well, now we can just plug this up into our original equation from the previous question. Y is equal to 10 cosine of pi over 30 times 138 plus 2. Okay, now we go to the calculator. Make sure we're in radian mode, because if we're not in radian mode, that's not going to work. So 10 cosine of pi divided by 30 times 138. Now we're going to close the brackets for the cosine function, and then we're going to add 12. There's our d. And it turns out, to the nearest tenth, she's at 8.9 meters above the ground. And there you go. So really, the issue with this question is please to remember that when you're dealing with a Ferris wheel, the D value must be larger than the A value. Please just remember that.
The height h in meters above the ground of a rider on a Ferris wheel after t seconds can be modeled by the sine function h of t is equal to 12 times the sine of pi over 45 multiplied by t minus 30 plus 15.
All right, so this question is kind of a repeat. We've done this one before. Determine the maximum and minimum heights of the rider above the ground. Okay, this is really similar to the tide problem we did a little while ago. So to figure out the maximum and minimum here, I need to know A and D. And I can read these right off the graph, and in this case, actually, this is really easy to do because the equation is even in the right form. The very first number that I come across here is the coefficient of the trig. So the amplitude is 12, and the median value, the D, is equal to 15. So the max that we get to is going to be D plus A. Okay, so 15 plus 12, 27 meters. The minimum is going to be D minus A, so 15 minus 12, and the answer is the minimum is going to be 3 meters. Okay, that's pretty easy to read right off of that equation, basically. The next question asks, or says here that tells us to determine the time required for the Ferris wheel to complete one revolution. That's basically just asking for the period. We know that the period is 2 pi over the b value. Okay, and again, I can go right up to here, and I can see the b value here. All of this is within the sine function here. My b value is pi over 45. So this is going to be 2 pi over 45. Now, the pi's will cancel, and then I've got 2 divided by 1 over 45. I'll multiply by the reciprocal here, and that's going to get me 90. And if you think back to the original question, the t was in seconds, so this is going to be 90 seconds. Okay, so now this question says, how long is the rider above 20 meters in one rotation? Okay, so this one requires a little bit more analysis. You just can't go to the calculator immediately and just get the answer. You gotta have to play with it a little bit here. So we're gonna pull out the calculator, we're gonna graph this thing. Okay, so we're gonna plug in our equation here, 12 sine of pi divided by 45 bracket x minus 30, close bracket twice, and then add the 15. And then we're interested in when we cross over the 20 mark. So we're going to put 20 in there. Okay, so we're going to look for where those things intersect. I got to adjust my window. Now, I already know that the period of this function was 90 seconds. So I'm actually going to go 0 to 90. And I don't know, I'll let my scale go by 9. It doesn't really matter, but that'll at least clean it up a little bit. I know from part A here that the minimum value was 3 and the maximum value is 27. So I'm going to let the minimum stay 0. I'm going to let my maximum go to 30, and I can leave that at 2, and then we'll just graph this. So right there is where I first pass 20. There's where we drop back below it again. So what I'm interested in is the difference between those two. Okay, so what I'm going to do here, first of all, is I'm going to go into my calc menu, second trace, grab intersect, and I'm going to find this first point of intersection right here, so you move close to it. Press enter for the first curve, enter, yes, and then the second curve, and then it's wanting to guess this number here. Just press enter and say yes. And we get this 36.15608. Okay, now I'm going to quit, and I'm going to call that number up. I'm going to press X here. Now, I tried doing something clever earlier with this question, and it didn't quite work here. So what I'm going to do is I'm going to store this number, and I'm just going to, remember, store is down here. Store is the button just above the on, STO. And then I'm going to press alpha math, and what that'll do here is it puts the A here. So I'm going to store this number in A. I'm not going to write it out. I'm going to let the calculator remember it here. So there it's in A. Now I'm going to go back to my graph, and I'm going to find that second point of intersection. So second trace to get into the calc menu, go down to intersect, and this time I'm going to move the cursor close to that other point of intersection. Doesn't have to be on it, just close. Press enter, it jumps to the second curve, press enter. It wants to guess this, just press enter, say yes. And then it gets me this number right here. Now I'm going to quit, and again I'm going to press X to see what it is, and it's this 68. Now, I want to find the difference between those two. So what I'm going to do here is, I know that this is X right now, so I'm X minus, and then I'm going to press alpha math to get A here. X minus A. So this will be 68.8 minus 36.15. That's the difference between them. So what does it say? Rounded, well, it doesn't say what to round it to, so we'll round it to the nearest tenth of a second here. So to the nearest tenth, this is 32.7 seconds. And that's what we're looking for in this particular question.